So last lesson we explored actually this idea of a discriminant. I didn't really formally introduce it. I was just trying to show you that there's actually a relationship between the discriminant and how many solutions we have to quadratic equations. But just to formalize this definition a bit more, right? The discriminant, or sometimes we write it, it looks like a triangle. It's technically the Greek letter delta. You might have seen that in physics. It represents like change or something like that, right? The discriminant tells us how many solutions there are to a quadratic equation. Because we know quadratic equations, they can either have 2, 1, or 0 solutions. The way I remember how that is like the discriminant, it's like discriminating. That's kind of like in a negative light. It's not really like, oh, I have 2 solutions, you only have 1 solution, right? It's just, not in a negative way, it just allows us to determine the differences between them, okay? Okay, now, where do we get this from? Remember, where does this come from? The discriminant is found from a part of our quadratic equation, right? Our quadratic equation, minus b plus or minus root b squared minus 4ac over 2a. This is where we find it from, right? It's that part underneath the square root. That is where our discriminant comes from. The way I see this, it's kind of like a hidden message. Has anyone read a Dan Brown book before? Does anyone know Dan Brown? Yeah, so he's written books like Angels and Demons. Sorry, what? Da Vinci Code, yep. The new one that just came out, well, not new, but it was on TV recently. It's called Inferno. And there is a scene in that movie where they look at this painting. It's called the Battle of Marciano. I don't know if I pronounced that right. But just look at the sheer scale of this painting, right? So this is kind of like scaffolding that they need to kind of do maintenance on the painting, right? So this is like all the scaffolding that goes up there. This is how tall a person is. This is how big the painting is. So it's a really big painting. But inside this painting, here's a more high-res version of it, okay? Do you want to flick the lights off, Joel, just really quickly? Now let's see if I can find this. What Dan Brown loves to do, he loves to put references to codes or hidden messages inside paintings. This one is that painting that I showed you before. It's really big. But if we try and zoom in, there's actually a hidden message inside here. Let's see if we can find it. Yeah, inside, on just one of these flags, there is an Italian phrase here. It says cerca trova, seek and you shall find. And that's actually a clue for those characters in the book to get to the next place or what they need to do, right? So just if you can't see that really clearly, this is the whole painting there, and this is that little hidden message, okay? That's how I kind of see the discriminant. Yeah, lights can go back on. That's how I see the discriminant, right? We've got this formula here, but there's this kind of like hidden message that says, okay, this is our quadratic formula. It allows me to find the solutions to a quadratic equation. But maybe I'm just interested in how many solutions there are. I can just look inside this part. This is a hidden message that I can see how many solutions there are going to be without actually having to go through the whole process, right? And just to recap again, right? Visually, we can see this in a few different ways. We can see it that there are 2 solutions. So where it touches the x-axis, it touches it twice. Okay, so the description I want you to write is touches the x-axis twice. Touches the x-axis twice. Do you have a question, Jacinta?
Yeah, so if you do that equation, would we still get 2 solutions?
Which one, sorry? This one?
The full equation, so the minus b plus minus square root.
So are you looking at this particular example?
No, just that. So you said if you use the discriminant, you get 2 solutions?
No, so sorry, just to clarify, the discriminant tells me how many solutions there are going to be.
Okay.
It doesn't find the solutions, right?
To find it, you would use the whole equation.
You still have to use the same equation. But in some cases, maybe all we're interested in is saying how many solutions are there, or if there's 0, are there going to be any solutions, right?
Okay, yeah.
So there's no point in wasting time trying to do this whole thing if I'm not even going to have any solutions, right? So it touches the x-axis twice. How many times does it touch the x-axis if I have just one solution? Just once. There you go. Touches it once. The x-axis once. And then obviously, if there are 0 solutions, it doesn't touch it at all. Doesn't touch. So I think that's what I want you to see. There's a connection, right, between an algebraic kind of thing, which is what we've been focusing on, just finding the solutions, and also a visual representation. We can see what that looks like, okay? Let's just go through a couple of these examples, right? We want to use the discriminant to determine the number of solutions to these equations. So just to reiterate, we don't want to actually solve them. We just want to see how many solutions would there be if I was to go about that. So what I would do is the first thing I would write is my discriminant is equal to b squared minus 4ac. And if you're still feeling a bit unsure about how to approach these, you can always write those letters down on the right-hand side. You don't always have to do this, but it's always just good practice to make sure you don't get anything confused, right? I've got a equals to 1, b equals to -5, and c equals to 3. And then I can just substitute those values straight in. So I've got -5 squared minus 4 times 1 times 3. And then you can just evaluate that, right? That's just 25 minus 12. That would just be 13. Once I've calculated the discriminants, I want to go back to my table and I want to say, okay, which condition does this meet? Yeah, it's the discriminant is greater than 0. It's a positive number. So because it's greater than 0, this is how I'm writing it out. I'm saying that because this is greater than 0, therefore, there are 2 solutions. Can you write that down for me? Therefore, there are 2 solutions. Same idea. I want to calculate the discriminant, okay? Can you tell me, Flynn, what are my a, b, and c values for this quadratic equation now? 1, 1, and 4?
1 minus 4.
Good. Okay, 1, minus 1, and 4. So again, you don't have to write the a, b, c values, but it's very easy to miss out on those negatives there. Okay, so it is kind of recommended. But let's just say I didn't want to write it. I'm going to be a bit lazy. I'm going to say, so b squared, that's -1 all squared, minus 4 times a, which is 1, times c, which is 4. I'm going to get here 1 minus 16. But hang on, when I evaluate that, that's a negative number. What do I know about that then, if I go back to my table? If my discriminant is less than 0, how many solutions will it have? None, right? If I go back to my table, just come back to this table, right? If my discriminant is less than 0, I'm not going to have any solutions. So just write a little note there. Therefore, there are no solutions. All right, 2 more examples. Then I'll let you try some yourselves, and I'll show you some trickier ones that Lucas wants to see. So. All right, so for the most part, same idea, right? We just want to find a, b, and c here. We want to find our discriminant. I know it's equal to b squared minus 4ac. Rhiannon, can you help me out?
No.
What are my a, b, and c values here that I'm going to substitute in?
A is 1.
Yep, what's b?
-2.
Good.
C is 1.
Minus 4 times 1 times 1. So I'm going to get, well, that's pretty nice. Actually, that's 4 minus 4, isn't it? Which is equal to 0. So therefore, I go back to my table. Oh, if it's equal to 0, that's right. There's one solution.
Look at me go. Yes, bitch.
Let's look at this next one. This next one's a little bit different. Chloe, can you tell me what's different about this question compared to the others?
There's no B. There's no B.
There's no b. Okay. What does that mean for the b value then?
It's just 0.
Another way you could write this, just to see that really clearly, right, is that it's the same as x squared minus 0x minus 36 equals to 0, okay? It's not that there's no x in there. In a sense, you can think about it as the coefficient of x just being 0, right? So again, just to make it really clear, I've got a equals to 1, b equals to 0, and c equals to -36. You can still calculate the discriminant for something like this. Your b value is just 0 here, right? So I've got the discriminant would be equal to b squared, or in this case that's 0 squared, minus 4 times 1 times -36. But be careful here, right? I've got a negative times a negative, which is actually a positive, right?
Whoa, good job, Chloe.
So that's greater than 0. Therefore, there are 2 solutions. Oh, that's not right. Sorry. What's 4 times 36? 144? Sorry. 144. Any questions about this one? What I've done here? No? Pretty good? Cool. I'll put some examples for you to try, and then I'll go through some harder ones.